Let's do 15, 16, 17 together in one video. Use synthetic division to divide these polynomials here. So x squared plus 2x minus 8. We're dividing that by x plus 4. All right. So synthetic division is an approach to division that utilizes just the coefficients of the polynomial that we're dividing. So let's pull out these coefficients. The coefficient of x squared is 1. Coefficient of x is 2. Coefficient of my constant is -8. And when you're doing this, you have to make sure that every term in descending order, every power in descending order is represented. So I have x squared, x to the first, x to the 0. Let's say this was missing. If 2x was missing and I just had x squared minus 8, I would need to put a 0 here to hold the place of that x to the first power. I need to have every power represented. So if this 2x wasn't here, this 2x was missing, I would still need a 0 to hold that place. So I don't need to write this here, but that's just like a visual reference. All right. And on the outside, the term that I'm using to divide, I'm going to change this sign. Instead of +4, I'll use -4. So when we're dividing by x minus c, change the sign to +c there. And that's what we use to divide. We do that to avoid the subtraction that happens in using long division to divide these things. All right, so the approach for synthetic division, only these coefficients here and that constant. Bring down the first coefficient. Bring it on down, bring it on down. Then we're going to multiply, add, multiply, add. Bring down the first, multiply, add, multiply, add. So -4 times 1 is -4. I'll write it up here. Then add these two together. -2 plus -4. It's 2 plus -4, sorry. -2. Multiply again. -4 times -2 is +8. -8 plus 8 is 0. This last number you get here, that's your remainder. Remainder of 0 means this binomial divides this quadratic evenly. It's a factor. I'll say more about that in a second. So when we're writing out this quotient, I started with x squared. Term with x squared is the leading term, and I divided by an expression with x as the leading term. X squared divided by x, that's just x. That's the power of x. That's what I was starting with. So I start with x squared, I go down 1 power to x. And then my next power down is my constant, x to the 0 power. If I had started with x to the 5th, this power would have been x to the 4th, then x to the 3rd, x squared, x to the 1st, constant. You're always going in descending order. Since I started with x squared here, the next power down is 1. The next power down is 0. So I'm there. So there's my division. So what this really means is x plus 4 times x minus 2 is equal to x squared plus 2x minus 8. In other words, that's the factored form. These are two factors. Because my remainder is 0, that means x minus 2 is a factor of x squared plus 2x minus 8. X plus 4 is also a factor, x squared plus 2x minus 8. 16. Use synthetic division and the remainder theorem to find the function value. So here's my function, f of x equals x to the 3rd plus 4x squared plus 3x minus 5. And we want to find f of -3. Of course, you might think, well, I can just substitute in -3. You can. The arithmetic might be a little heavy, but you can. You can certainly substitute -3, but that's not what the problem is asking you to do. The problem is asking you to use synthetic division. And if you use synthetic division, what the remainder theorem says is if I have f of x equals something, I have some function, right? And I want to evaluate that function at a value, the remainder theorem says just use synthetic division right? Use synthetic division. Use these coefficients. 1, 4, 3, -5, x to the third, x squared, x to the first constant. The remainder theorem says use synthetic division, right? And whatever you get as your remainder, is f of -3. If I'm attempting to evaluate a function at a value, use synthetic division. What do I use out here? Same number, use -3. Don't change the sign for these. You only change the sign if I'm using x plus 4, x minus 4, what have you. But if I'm evaluating at a value, use that same sign. Use that same sign. Use that same sign, the same sign. Divide using synthetic division, and that remainder is the function value. That's what it says. I'll even write it out. When f of x is divided by x minus c, the remainder is equivalent to f of c. When f of x is divided by x minus c, the remainder is the same thing as f of c. So this remainder is going to be f of -3. Let's bring down the first coefficient. Multiply, add, multiply, add, multiply, add. So this means f of -3 equals -5. That's what we're trying to find right there. That's choice B. I'll even verify it here. Let's substitute -3 and see what happens. Alright, f of -3. -3 times -3 is 9. 9 times -3 is -27. Plus 4 times 9. That should be a -3, right? Oops. -9. -5. See, that's the kind of thing that happens with evaluation that you might not get with synthetic division. Notice how all these numbers are so small. The absolute value of none of these is greater than 5. But over here, I've got -27. I've got a plus 36, -14. Got some values to contend with. -27 plus 36 is 11. No, that's 9. And 9 minus 14 is -5. So I get the same solution. F of 3 is -5. Then 17. So use the remainder theorem to find the remainder when f of x is divided by x minus c. Look, we have it. I wrote it right here. When f of x is divided by x minus c, no, f of x is divided by x minus c. Same language. See that? See that? When f of x is divided by x minus c, the remainder, to find the remainder is equivalent to f of c. So here I'm dividing by x plus 2. Right? So the remainder is equivalent to f of, so change this sign, right? See f of c? Change that sign? Change that sign? So the remainder is equivalent to f of -2. If I substitute -2 into this equation, this function for x, I will get the remainder. Substitute -2 for x. -2 squared, that's 4. Minus 4 plus 5. F of -2, 4 minus 4 is 0. F of -2 is 5. That's my remainder. B. My remainder is 5. F of -2 is 5.